Okay, in the last class, we start series, infinite series with the positive terms, and then we denote the sum is summation A. Okay, so there are two processes. Given any sequence Sn, we have a series. It's nothing but just to add all the terms of the sequence. So we call this series. Okay. Now, when we say this series is converges, when we say this series is converges series, if we have to define new sequence, better usually we denote Sn is the partial sum, so we can take some other notation, some An, and then summation An is the series. Now, when we say this series is converges, you have to find the partial sum. If the partial sum is converges, then the series converges. Okay, so when this series is diverges, if the partial sum Sn is diverges. So what is the partial sum? Just Sn is nothing but sum of first n terms of the sequence series. Okay, if the sequence is converges, then the series is converges. Now, so it is enough to show the sequence partial sum is converges. It is because this Sn is always less than or equal to Sn plus 1. If all the Ans are positive or greater than or equal to 0, then this partial sum is an increasing sequence. So if it is increasing and bounded above, and the sequence Sn is bounded above, then the series is converges. Is bounded above, then the series is converges. Then summation An converges. And then it is enough to show that this Sn is Cauchy, all the things we studied. And then we discuss some important examples of some theorems of series. The sum of two convergent series is convergence. And suppose if the series is convergence, the nth term converges 0. That is very important thing. And that now today some more important series we are going to discuss. Now the first one. So example. If you consider the geometric series. Geometric series. So geometry series is of the form 1 plus r square plus and so on plus r power n plus and so on. So this is geometric series. Positive. Each what is the condition on r? R should be positive. So r is greater than or equal to 0. Then this series is called a geometric series. And this series convergent only if and only if. Only condition r should be less than 1. So already we know that r is positive. Now r should be strictly less than 1. If you take r equal to 1, what will happen? If you substitute r equal to 1, the series become 1 plus 1 plus 1. The sum is not a finite value. Okay. Therefore, if r equal to 1, the series is diverges. But if r less than 1, the series is converges. Why this series is converges for r equal to 1? What is the partial sum? So the partial sum of this series Sn is nothing but first sum of first terms, first n terms, plus etc. plus Rn power n. And we know that the value of this first n value is nothing but 1 minus r power n plus 1 by 1 minus r. Already we proved this. Okay. Now as n goes to infinity, this Sn approaches to, because r is the lesser one, already we proved that Rn converges to 0 if r is strictly less than 1 and then positive. R is modulus of r is less than 1. Okay. So here r is less than 1. Therefore, this r power n plus 1 converges to 0. Others are constant because this denominator 1 by r is a constant. Therefore, constant sequence converges to the same number 1 by r. Therefore, this converges to 1 by 1 minus r. Since the partial sum is convergence, therefore the series is convergent. Therefore, what is the value of this series? Nothing but 1 by 1 minus r. Therefore, summation r power n, where n equal to 0 to infinity. Because if substitute n equal to 0, we get 1. So this series converges. The sum of the series is nothing but 1 by 1 minus r. So this is geometric series. So usually in school days we study the geometric series, but we have to multiply a. That is every term contains a. That is a plus AR plus AR square, etc., AR power n, and so on. So usually we studied this is geometry series for any A is positive. Then you can take A outside, we get 1 plus R plus etc. power 1 and so on, right? Therefore, this series values A into, we know values 1 by R, that is 1 minus R. In the previous case, usually we take A equal to 1, we consider as a geometry. So anyway, this is also geometry, so provided R should be positive and then should be less than 1. So the series geometry converges only for these values. Okay, it's a very important thing. If R is equal to 1, that is diverges because we get 1, 1, 1. The nth term is nothing but what is, okay. So case, if you take R equal to 1, so what is Sn? Sn is nothing but 1 plus 1 plus 1 because everything is 1. Therefore, we get n. So we know that as n goes to infinity, this diverges to infinity. Therefore, for R equal to 1, this diverges. If R is bigger than 1, again R is bigger than 1, therefore R power n is bigger than 1 for any n. R square is also bigger than 1, R cube also bigger than 1. Therefore, in Sn is nothing but 1 plus R plus etc. plus R power n. This R also, so already we have 1. This R is bigger than 1, therefore plus 1, plus etc. plus this R power n also bigger than 1, therefore this is nothing but n. So therefore this Sn is bigger than n, therefore is not bounded above. If it is convergence, should be bounded above, but we get Sn is bigger than n. Therefore for R greater than 1, the geometry series is diverges. For R less than 1, we already proved that this Sn converges to 1 by 1 minus R. Okay. Now, another important example is sometimes called P series. Some books are referred lambda series. Okay, anyway. So usually we call P series. Okay. P series are harmonic, generalized harmonic series, or a generalized harmonic. So harmonic series is nothing but summation 1 by n, but a generalized harmonic series is nothing but summation 1 by n power p for some p greater than 1. Generalized harmonic series are sometimes called P series. Okay, so it's nothing but the positive term summation 1 by n power p. So this series is called summation n equal to 1 to infinity. Actually, this series is called where p greater than 1. Okay, so this series is convergent. When this series is convergent, if and only if this p should be strictly greater than 1. Okay, if p equal to 1, that is a geometric series. We already proved that 1 by n series is not convergent. But 1 by n power p, where p is bigger than 1, is always converges. Okay, it's a very important thing. So therefore, sometimes they will ask, is the summation n power minus 3 by 2 is converges or not? So this is nothing but summation 1 by n power 3 by 2. Okay, since 3 by 2 is bigger than 1, therefore as this is p, this is 3 by 2 series, therefore it converges. But p is any real number, it's not an integer or anything. If p is any real number, but if it is greater than 1, then summation 1 by n power p is converges. For example, n power this n power minus 3 by 2 is converges. Now tell me that summation 1 by square root of n is converges or diverges? Yes, n equal to 1 to infinity. This is nothing but.
So your voice is breaking in between, sir.
Okay. Now it is okay, or again still any problem? It's again breaking. Hello.
Sir.
Now is it okay, or yeah. Okay? Yeah, tell me.
It does not converge, sir.
Okay, please wait. Hello?
Yes, sir.
Yeah, okay. Now this not converges. Yeah, very good. It's diverges. Why? Because this limit 1 by n power root limit 1 by 2. So this is a p value. So here p is 1 by 2, but is strictly less than 1. Okay, if it is converges, p should be bigger than 1. Therefore, this is diverges series. Okay. So therefore, this geometry series and then this p series are very important series. So we can say some other series using these. We can say easily converges or diverges. Okay. Now we have some important limits of the sequence. You should remember. So quickly we recall what are the important limits of the sequence. Some important limits of the sequence. Limits to remember. Remembered for direct application. So the first one is the first limit of the sequence is n power 1 by n. So limit n goes to infinity, n power 1 by n. This n power 1 by n sequence converges to 1. Therefore, the limit is 1. So now the second limit is log n by n. So limit n goes to infinity, log n by n is value is 0. Why this value is 0? So substitute n goes to infinity, log infinity is infinity by infinity by infinity form. You have to apply the L'Hospital rule. Therefore, we have to differentiate numerator and the differentiate denominator. If we differentiate denominator with respect to n, we get 1. In the numerator, we get, if we differentiate 1 log n, we get 1 by n. So this is nothing but 1 by n. Now as n goes to infinity, we get 0. That's why the limit is 0. Okay. Now the third limit n goes to infinity, 1 plus x by n. X is any real number. Power n is nothing but e power x. Now the fourth limit is, suppose instead of power n in the previous third problem, we have n plus some p. So that is limit n goes to infinity, 1 plus x by n power some n plus p is always e power x. Already we proved this one. We got to split this into product of this power n, power p, but the power n converges to e power x because of by 3, and this is 1 plus x by n. So this is nothing but power p means what? That factor is multiply p times. That is what is the factor 1 plus x by n into 1 plus x by n and so on. Okay. As n goes to infinity, this goes to 1 and this goes to 1 and so on. Everything goes to 1. Therefore, product goes to 1. That's why we get just e power x. Okay. Provided p should be finite number, maybe positive or negative, anything, but b should be a finite number. It's not an infinite number. Okay. Now, the next one maybe is sometimes very important thing. Suppose we have a polynomial. So limit n goes to infinity. We have a quotient of two polynomials. The numerator we have some c naught into n power p. It's a degree p polynomial in terms of n. Some c1 n power p minus 1 and so on. Some cp minus 1 into n plus cp. This is just a polynomial of degree p. Suppose we have another polynomial in the denominator, some d naught times n power some q, some d1 n power q minus 1 and so on plus dq. So what is the limit of these sequences? Okay, there are three cases. Suppose if p equal to q, suppose both are same, then you can from this numerator you can take n power p outside. And then again, since p equal to q, the denominator also you can take n power p, cancel as n goes to infinity. The first two terms does not contain any n because you are taking n power p and the n power q outside, we can cancel. All other terms contains 1 by n, some at least 1 by n. As n goes to infinity, everything 0, we get only C naught by D naught. So if P equal to Q, we get the limit is C naught by D naught. If this, suppose P is smaller than Q, then what will happen? We get 0. For example, suppose in the numerator we have n cube, suppose in the denominator we have n power 5. We can cancel n cube and then we have 1 by n square. As n goes to infinity, 1 by n square goes to 0. That's why I'm writing here. Now suppose Q is smaller than P. Oh, sorry, I did mistake. So this is the case. I'm writing here, right? So for Q is smaller, the denominator is bigger, then it goes to 0. Is the numerator is smaller than denominator, then it goes to 0. Then what happened? If this one, the reverse one, P is smaller than Q. So for example, n power 5 by n cube. The denominator is small power means we can cancel in. We get n square. As n goes to infinity, it goes to infinity. Okay, provided both C naught and then D naught is positive. Otherwise, it goes to minus infinity. So C naught is positive, and then the constant of D naught is also positive. We get this converges to plus infinity. Anyway, we can take some powers of n and then cancel. After that, we got to consider what as n goes to infinity, where this goes. Sometimes
Sir,
it is useful.
If P is less than Q only, then it will 0, no, sir?
Please wait. Okay. I am considering the numerator is P, right? Okay. Yeah, thank you. So that's a mistake. I am thinking the numerator is Q. Yeah. So therefore, this is so the denominator is small, right? Therefore, this is infinity and this is 0, right? Okay. And then in this case, this is a case for the infinity case. Both C naught and then D naught should be positive. Otherwise, we get a negative minus infinity. And that's why we got. Okay, these are all important limits of the sequence. Using this, we can easily say a series is converges or not. Okay, now we have some already we discussed the one test, that is comparison test. So quickly we recall what the comparison test says. So comparison of test of first type. Comparison test of the first type. So what is the comparison test says? Suppose we have two sequences. Okay, suppose let summation un is a one sequence series and summation vn be two positive terms of series. Positive terms, so that is very important. Positive terms of series such that one sequence term, that is un less than or equal to vn. Okay. Before that, maybe I can state in the next step, such that suppose if one series is convergent, suppose for A, suppose summation Vn is convergent, is given. And we have a after certain stage, so that is there is some stage n naught in n, such that if we take un is always less than or equal to Vn for every n after this some stage. Maybe the first finite number of terms may be different. Okay, maybe uns are maybe bigger than Vns for finite number of steps. So after certain stage, these uns are less than or equal to Vn for each n, then this summation un is convergent. If this is convergent series, then the comparison test says summation un is convergent. So need not be this is happened for every n. Maybe for except some finite number of terms, this is happened. Then the summation un is convergent. Okay. If the bigger series is convergent, then smaller series is convergent. If the smaller series is divergent, then bigger one is divergent. Okay. That is test for divergence. This is test for convergence. Okay, we can say this is test for convergence. Test for convergence. Suppose you want to test the given series summation un is convergent. If it is possible to find a convergent sequence vn satisfying this un less than or equal to un less than or equal to vn, then it's a convergence. So the next test is test for divergent. So you should know examples of both the convergent series as well as divergent series. That's then it's very useful to check for other series. Okay. So what is the test for the convergent series again? So the same story I'm writing such that the first one is suppose summation un is divergent. Okay, same story you got right in the beginning. And then suppose there is again for certain stage there is some m in n. After this stage, all the uns are less than or equal to vn. For every n which is greater than or equal to this stage m, then summation vn is divergent. If the small sequence is divergent, then the bigger sequence is divergent. Okay, is divergent. So this is a test for divergent. Okay. So and then we have another important theorem is there. I will state that and then we discuss some examples. So the next one is the practical comparison. So there is some other thing. So that is suppose we have two sequences, series summation un. So we are assuming that all the terms of the series are positive, non-negative. Okay. So keep in mind. So these uns are non-negative, and then this series vn, all the vn's are positive terms. Okay, these are all series. Okay, and suppose such that what is the condition satisfied? You can find the limit of this un by vn, because the nth term of the series and then the nth term of another series, you have to take the quotient and then take the limit n goes to infinity. Suppose you get some non-zero value n, where L is a non-zero number. If you get the limit is L non-zero, then the theorem says, then if you know about one series, then the similar for the other series. Suppose the numerator un is convergent, then vn is convergent. Suppose vn is divergent, then un is divergent. So the two series. So both these two series identical behavior relation in relation to the convergence. Then the two series summation un and then summation vn have identical relation behavior or identical behavior. Both have same behavior. If it is one series is convergent, then another series is convergent, provided the quotient limit should be non-zero number, maybe negative or positive. But if it's not equal to 0, then definitely both have same identical behaviors in relation to convergence. If it is convergence, then convergence. Divergence, it is divergence. So in relation to convergence. Okay. Okay, but now we solve some problem and then we move to the next test. So comparison test is more useful, but that is not the only test to say a series is convergent or not. Okay, so maybe this is a first test. Okay, first you got to try to apply this comparison test. Okay, examples. Now first one. examine the convergence of infinity series. The convergence are not, you have to say summation 1 by n square plus a square. Now tell me, is this convergence? You have to apply this comparison test. So that is, you take u1 is 1 by n square plus a square, where a is any real number, therefore a square is always positive. Now, can you find any sequence bigger than this? Suppose I am taking 1 by n square. So how I get this one? Because of using these, because they have 1 by n square plus a square. So we know that n square is always less than n square plus a square, because less than or equal to some. If a is 0, we get equal. Otherwise, strictly less than this one. So now anyway, if you take this 1 by n square plus a square this side, and then if you divide by 1 by n square, we get this one. Okay. Now I am going to choose Vn equal to this. Already we call this is Un. So I call this is Vn. Vn is nothing but 1 by n square. Now I know about this series of this term, because this is nothing but 2 series. Okay, you have P here, P equal to P equal to 2. Since we know that the summation 1 by n square. So this is true for this relation is true for any n, right? Therefore, this is true for any n bigger than or equal to 1. From n equal to 1 onwards, this is always true. Okay, the stage is 1 here. So since we know that this series is converges, why? Because the power n power t, where t is here 2, bigger than 1, therefore it converges. Since the bigger series is converges, therefore the smaller series is converges by comparison test. Therefore, summation un is converges or convergence and convergent. So got it? Any doubt? Okay. So idea is you got to choose such a sequence Vn from the given nth term of this given series. It is n square plus something. You just take n square, and then you get a relation. Okay. Now, please guess. I give the second one. Please guess. Suppose summation Bn minus A by Bn square plus A square. So check whether this series is converges or not. So take this is Un. So Un equal to some A, B or some fixed number, fixed non-zero number. Bn minus A by Bn square plus A square. So how we can choose Vn? So actually in the Vn, don't bother about the constant AB. If you want, you can remove all of this and then you can choose. So I'm going to check. I'm taking 1 by n square. Okay. Numerator you have n, so better I'm choosing Vn equal to 1 by n square. Now is this always true? Un is less than or equal to Vn. Now we have to check. That is b times n minus a by b times n square plus a square is less than or equal to 1 by n square. Is this true or not? So you have to just cross multiply and then we have to check. Otherwise, it's very difficult to check. Then better you have to apply the second result. What is the second result? You have to find a quotient un by bn or bn by un. So depending upon your wish. So I know un, I know bn. So now find the limit. First you have to take un by bn. So what is un? Bn minus a by bn square plus a square anyway. And then by bn, therefore bn is n square, it will get the numerator is n square. Now from the denominator, we can take n square is outside. Therefore we get b plus a square, a by n whole square anyway. And then in the numerator we have a n square. Now what will get? N square times Bn minus A. Sorry, so then, we have a problem. So we take, because we have one more n is there. Therefore, better we take 1 by n. Okay. So again, from the numerator also, I am going to take n outside. Therefore, we get n into n square. So therefore, here we get this, we get a denominator is n. Now n square is cancelled. So as n goes to infinity, this goes to 0 because it's 1 by n. Therefore, the numerator we have b. The denominator, again, this is the 1 by n form is there. Therefore, goes to 0. We have b. So bb cancel, we get 1. It's a non-zero number. Therefore, the quotient we get a non-zero number. Therefore, both the series have identical behavior. And we know that the summation Vn is divergence because summation 1 by n is divergent. Okay. Since we know the summation 1 by n is divergent and the quotient is 1, therefore, the summation Un is divergent. Okay. Now, maybe one more example we will discuss. Third example, suppose if we consider this series summation square root of n by n power 4 plus 2. Now we can choose Vn and then find the quotient what we will check. So therefore, we take Un equal to the square root of n by n power 4 plus 2. So I am going to cancel this numerator n and then denominator 1n. So what can I do? So first you have to try to simplify this. So this is equal to n into, if we take n power 4 outside from the denominator, we have 1 plus 2 by n power 4. Now anyway, we can cancel 1n. Therefore, we get square root of 1 by n cube into 1 plus 2 by n power 4. You can take this 1 by n cube outside from the root. What will get? 1 by n power 3 by 2. Because root 2 we have 1 by 2 into square root of 1 plus 2 by n power 4. So this is our Un. Now guess Vn. So it's nothing but 1 by n power 3 by 2. I am going to take Vn equal to n power 3 by 2. Now find the quotient Un by Vn. So therefore we have 1 by n power 3 by 2 into square root of 1 plus 2 by n power 4 by 1 by Vn. So 1 by Vn is we get again into n power 3 by 2. So we can cancel n power 3 by 2 and then apply n goes to infinity. Numerator we have 1. In the denominator this goes to 0. And we have 1. Square root of 1 is 1. So this is nothing but 1. And this is a non-zero number. Therefore, both the series have an identical relation. And we know about this series. What can you say about summation 1 by n power 3 by 2? So since 3 by 2 is bigger than 1, by P series, this is converges. Because this 3 by 2 is bigger than 1. Since this is converges, therefore summation Un also converges. Because both have identical behavior. Therefore, summation Un is converges. Okay. Now, maybe one more example in that thing. So, suppose we have considered the series 1 by square root of n plus square root of n plus 1. What can you say about this series? So, therefore, Un equal to 1 by square root of n plus 1 by square root of n. So, what is your guess, Pn? 1 by, I am going to, suppose some constant is add with the n, we have to omit that constant and then take the remaining thing. So, root n plus root n, suppose I am taking square root of, 2 into square root of n. Okay. Now, I am going to show that this Vn is less than or equal to this Un. Is always true. or you can apply this quotient. Anyway, you can apply the quotient also, that is not an issue. Okay, now what is un by bn? The quotient un by bn. So therefore bn we have 2 times square root of n. The denominator we have square root of n plus square root of n plus 1. Now what will get? What is the value? If you take 2 times root n, so from this first term you can take root n outside, therefore 1 plus. So from this you can take n outside, that's why we get root n, therefore square root of 1 plus 1 by n. Right? Now root and root n cancel, as n goes to infinity, this term goes to 0, therefore this term is 1, therefore 1. Therefore this is equal to 2. Sorry, we have denominator is 2, converges to numerator, converges to denominator, this is converges to 1, this is 1, 1 plus 1 is 2. So 2 by 2 is 1, we get a non-zero number. Therefore both the series have an identical relation. Now look at this bn, summation 1 by 2 times square root of n. This is diverges because don't bother about this constant, n power 1 by 2. 1 by 2 is less than 1, therefore this series is diverges. Since this is diverges, therefore summation v and un is also diverges series.
Sir, this will work if we take Vn is also Vn equal to 1 by root n, no sir?
Vn equal to 1 by?
Root n, sir. Then also we will get the same, no sir? We get 1 by 2 instead.
Yeah, you can take that also. Anyway, you have to produce some sequence Vn. The quotient is, we get a limit is non-zero value, then both have this thing. So, so usually if you add, yes.
Sir, I can take Vn as 1 by n or 3 by 2, no sir. That is also possible.
N power 3
Like
by
on
2.
what basis we have to take Vn, sir?
Yeah, so in the you have to look at the Vn. So first you have to look at the Un. So from this we have to construct guess, actually our guess. So I am just suppose here adding with the plus 1, just I am omitting this one and then take the remaining. So in the first beginning example, n square plus a square, I am just removing this constant. Wherever they add to the number n or n square, I am just removing the remaining terms. I am taking 1 by n square. Okay, this is just a guess. You can work any other thing also. Okay. If you take some other example, if you get a non-zero number for convergence series, then this converges. But you will not get any Vn such that quotient is non-zero number, but Vn is convergent. That we cannot get any such a series for this problem, fourth problem. Even if you take a Vn equal to 1 by n power 3 by 2 or anything, you will not get any finite value. Maybe you get infinite, the limit may be infinite, but we need a finite value. That value should be non-zero value. Sometimes you'll get zero value in the quotient or infinity. Suppose you try to prove this un is converges, but it's a diverges. Okay. Now we have another example. So there are some lot of examples there. Maybe I will. These are all important examples. That's why I am discussing here. So maybe the fourth one. What can you say about the series 1 plus the second term is 2 power 2. The second term is 3 power 3, 4 power 4, and so on. So therefore, the nth term is 1 by n power n, and so on. So this is a series. Now, what is the relation between this 1 by n power n and then any other known series? This look like some geometry, but this is not geometry series, but just to guess 1 by 2 power n or 3 power n or 4 power n, everything. So because both have a power n, that's why I am choosing like this. So we know that 2 power n is less than n power n, but this is whole after n greater than or equal to, or n better we take n greater than or equal to 3, that is not an issue. Okay, for n equal to 2, we get strictly that is 2 square, that is strictly less than, that is not true, but this inequality holds for n greater than or equal to 3. So therefore, if you multiply these divided by 1 by n, then we get this relation. Now, we know this is a geometry series and this is converges to 1 by 1 minus 2, that is we get 2. Therefore, this is converges. So summation 1 by n power n is convergent by comparison test. Convergent. Because this 1 by n power n is less than or equal to 1 by 2 power n. And we know that summation 1 by 2 power n is a geometry series, and we know that this converges by comparison test, this is converges. Okay. Okay, you should know the relation between some known numbers and then the given number. That's it is to check the series converges or not. Okay, now maybe the similar problem. One more problem is that how to guess Vn. Suppose we have a series like a summation 1 by summation not 1 by square root of n power 4 plus 1 minus square root of n power 4 minus 1. Now what can I say about this series? So therefore un is nothing but square root of n power 4 plus 1 minus square root of n power 4 minus 1. So you cancel the n's in the numerator, we have to make in the denominator, therefore we have to multiply and then divided by the same number, that is the same number is n power 4 plus 1 plus square root of n power 4 minus 1 divided by the same number n power 4 plus 1 plus square root of n power 4 plus 1 minus 1. In the numerator, a plus b into a minus b formula, that is a square minus b square, therefore square means root cancel, we get a n plus 1 minus of n power 4 minus 1. In the denominator, we have n power 4 plus 1 minus square root of, plus square root of n power 4 minus 1. So in the numerator, n power 4 cancel, and 1 plus 1 we have 2. So 2 by square root of n power 4 plus 1 plus square root of n power 4 minus 1. Now guess Vn. Anyone guess Vn? So I already said that anything add to that number, we have to omit that and then take a remaining thing and then sum, you get so.
1 by n root n power 4, sir.
That is what is root n by 4. Square root of n power 4.
N squared, sir.
Yes, nothing but n square. Yeah. Now we find this one. Now take the quotient. You have to check what is un by vn. So therefore, we get a numerator is n square. In the denominator, we have already un, we have 2. And here square root of n power 4 plus 1 plus square root of n power 4 minus 1. So from this, you can take n power 4 outside. Therefore, it come outside n square. Again, from this, you can take n power 4 outside. You get n square outside. Therefore, totally n square cancel if we take common, right? Therefore, we get 2 by square root of 1 plus 1 by n power 4 plus square root of 1 minus 1 by n power 4. As n goes to 0, n goes to infinity, this goes to where? Where?
Infinity, sir.
Why? Because this is goes to 0. But we have 1, therefore square root of 1. Here again
yes,
1 by n. This also, therefore square root of 1 plus square root of n, this is but 1 plus 1, 2. Already numerator we have 2, to cancel we have 1. So since we have the quotient is a non-zero number, the limit is non-zero number, therefore both series have identical relation. Now we know that summation this 1 by n square is convergent because here p is 2. Since this is converges, therefore the given series summation un is converges. Convergent or convergent. So you have to guess Vn from un. Just you have to omit that constant. You have to some number that add to the n square or n power 4 anything. Just to remove that constant and then guess that. Okay, that is a idea. Okay. Maybe now some more examples we will discuss. So if you discuss some more examples, you can get some ideas how to choose that. So depending upon the problem, we have to choose. So what is the summation sine of 1 by n. So what can you say about summation sine n? Is this convergence or divergence? Okay, anyway, you come to this and then you can, because if you consider only sequence, sine n is divergence. Okay, keep in mind. Okay, anyway. Now, what is our un? Is sine 1 by n. And can anyone know the value of this as you studied in school days or in your class, sine x by x? As x goes to 0, what is the sine x by x value? It's
One,
absolute.
sir.
Yeah, 1. So now guess what is Vn? In the question, I am going to get some non-zero limit. And then
Sine 1 by n by 1 by n. Can we take, sir?
No. Anyway, that is a quotient of these two. Then what is Vn? Just to take 1 by n. Now look at un by Vn. So this is nothing but sine of 1 by n by 1 by n. Okay. So as n goes to infinity is same as 1 by n converges to 0. Okay. So look at the same thing here. Therefore, as n goes to infinity, this goes to where? 1. Okay. Therefore, this is a non-zero number. Therefore, we know that summation Vn is 1 by n, is divergent series. Therefore, implies summation sine 1 by n is also divergent. Got it? Okay, maybe this example you can quickly you can see the answer. Okay, so 7th problem. Summation 1 by, I am taking n power alpha plus 1 by n. Can anyone is converges or not? So what is our un? Un is nothing but 1 by n power alpha plus 1 by n. I am not saying anything about alpha. Okay. So therefore, you have to specifically inform for what values of alpha this is converges. For this value of alpha, this diverges. Okay. Now, what I am going to choose? Vn.
1 by n
1 by n.
1 by n.
power alpha.
Okay, we will check. If we take alpha or 1 by n, we will check. Okay, so better because we don't know about alpha. Okay, so we try to cancel that alpha. That's why I'm taking 1 by n power alpha. Okay, good. Now check what is the quotient. Un by Vn. No need to find un by Vn. You can find Vn by un also. That is possible. Okay, that is your wish. So depending upon things. Therefore, what you'll get, this is actually n power alpha by n power alpha plus 1 by n. So actually n power alpha we can cancel. We get 1 by n power 1 by n. So this goes to where? 1 by n power n converges to
1.
1. Therefore, this totally converges to 1. Therefore, this is non-zero number. Now, what can you say about this convergence of this series? When this series converges, summation Vn.
For alpha less than, greater than 1.
Yeah, if alpha is greater than 1, then okay, we can directly write the given series. Okay, so for the given series summation un, that is nothing but summation 1 by n power alpha plus 1 by n is convergent if alpha greater than 1. Divergent if what? Alpha less than or equal to 1. For the remaining terms, for remaining values of alpha, that is divergent. Because convergent only when alpha should be positive. Okay, so that's it. So depending upon alpha, the series converges or diverges. Okay, any doubt in this? Okay, one more final example we will discuss. 1 by 8 problem or something, summation 1 by n 1 plus 1 by n. Is this converges? So directly you can see, if this converges, then what will happen? What can I say about the nth term? If it is converges, suppose this is converges.
Tends to 0, sir.
But this converges to where?
1.
Yeah, 1. Because 1 by 0, therefore converges to 1. Therefore, clearly, directly you can say this is divergence. Otherwise, suppose you want to say using this theorem, then you got to guess Vn. Now guess someone, this is Un, guess some Vn.
One by n, sir.
Okay, suppose we will work with 1 by n. Okay. Okay, now Un by Vn. So therefore we get n. Here we get 1 by 1 plus 1 by n. Now what will get? What is the limit? You will not get any finite value. So then what we have to do? See, look at this example, the previous example. And then
So once if we take Vn as 1 alone.
Again we get 1 means what? 1 series. What can you suppose if you take Vn equal to just n? Just n, what will happen? Again we will not get, because n into we get the diameter n. Therefore we get this. You multiply n, inside we get 1 by n plus 1. This converges to 0, but we don't get any non-zero value. So this we cannot say this if you take Vn equal to this. Anyway, so directly we can say this is divergent because the nth term not converges to 0. Therefore, we can directly say it's converges, diverges. Okay. Otherwise, you can say, say somebody says everything is 1. If you take 1, all the Vn's are 1. Therefore, Un by Vn is nothing but 1 by this. This converges to 1. Therefore, this series is diverges. Therefore, this series diverges because summation 1 is nothing but 1 plus 1 plus 1 1. This is not a convergence series. So keep in mind. So first of all, suppose if you see some series, first you have to check the nth term converges 0 or not. If it is not converges 0, you can directly say it's diverges. Okay. Now one more things are there. Okay, we will discuss that in the problem tutorial sheet. Some other problems. Okay, now there are some problems there. Next, this is the first type. So far we discussed a comparison test for first type. Now what is the second type? So second type is similar to that one. So same thing, maybe I can write here. Instead of un vn, you have to take the un plus 1 un and then vn plus 1 vn. So that is same story. Okay, summation un is one series positive terms, and then summation vn is another positive series. And suppose okay, first write summation vn. Suppose one series is convergent, and second is again after certain stage, after some stage, some m in n, there is some stage. So we have a un plus 1 by un is less than or equal to vn plus 1 by vn for all n after this stage m. Then the series is convergent. The summation smaller series un is convergent. un plus 1 by un less than or equal to vn plus 1 vn for every n greater than or equal to after certain stage, then the smaller series is also converges. So this is test for convergence. Similar for test for divergence, same story, but I'm taking the smallest one. Summation un is divergent. Okay, un is divergent. And again, after certain stage, there is some stage m such that un plus 1 by un is less than or equal to vn plus 1 by vn for any n greater than or equal to this stage. Now summation un is divergent. That is small series is diverges implies the bigger series vn is diverges. So what is the difference between the first type, second type? Only thing, this comparison. So in the first type, we compare only the nth term of un and vn. But here, the quotient of nth term, n plus 1th term of both the things. Okay. Again, one more, the next test. D'Alembert's test, ratio test. Sometimes called ratio test or D'Alembert's test. So given any series, you know, but in the comparison test, you need another series. Okay, but in the ratio test, you no need any new series. Okay, sometimes called D'Alembert's double rotation ratio test. Okay, what the test is, suppose we have a series summation some an, where an's are positive terms. If it is 0, we don't bother about this one, because 0 plus anything is same number, right? Suppose we have a series positive terms such that if you take this n plus 1th term quotient by the nth term, if you find the limit of this, suppose you get some value L, okay, then the series is converges if L is less than 1. Then first one we can say converges, the series is converges if L is less than 1 and diverges is greater than 1 if L is greater than 1. No conclusion if L equal to 1. Otherwise test fail. Okay. Otherwise no decision is possible or no decision make. Sometimes maybe converges or diverges. Okay. So no decision. Otherwise test fails. We cannot say anything about the convergence or divergence of the series if the value L equal to 1. Okay. So keep in mind n plus 1th term by nth term. If it is less than 1, the limit is less than 1 is converges. If it is greater than 1 is diverges. So suppose instead of you are taking n plus 1th term by nth term, suppose you are taking nth term by n plus 1th term. Okay, and then you are finding the limit. You get some L. Okay, so if L is here less than 1, if L is greater than 1, it converges. If L is less than 1, diverges. Okay, if L equal to 1, no conclusion or no decision. So keep in mind what you are taking, an plus 1 by an or an by an plus 1. So better you take an plus 1 by an. So that is a good thing, because always less than 1 means converges, greater than 1 means diverges, L equal to 1 means what? Sometimes converges, sometimes not converges. Okay. And then we have to move to the next result, next test. Suppose if the D'Alembert's test fails, then we move to the next test. The ratio, first you have to check the ratio test, and then if it is not work, then we go to the D'Alembert's test, and then some Rabbit's test, a logarithmic test. There are a lot of tests are there. Can check one by one. Okay. Suppose if you take the quotient limit, if it is L is a number, we can say either positive or negative, the 0 or anything. If we get some finite number, we can say it's converges or diverges. Suppose the quotient limit an plus 1 by an is infinity, then we can directly say it's a divergence series. Okay, so this is the first part. Okay, the second part, suppose the limit is infinite. So limit n goes to infinity, either un plus 1 by un. Suppose this we get infinite, then the series is diverges. Then summation, okay, I'm taking an, right? So summation an is divergent. Okay. Again, for the an by an plus 1 also infinity, then we can say it's a divergent. Okay, same thing. Either an plus 1 by an, or suppose you are working with an by an plus 1. Again, we get infinity. Then again, the series an is divergent. Okay, so keeping it. Oh, sorry. This converges because we get a 0. It's infinity means we get 0 or 1 by n. So they converges. Okay, because L is bigger than. Now we solve some problems to check whether this is true or false using the comparison test of second type and then these things. Okay. So better we check ratio test, sorry, DLMS ratio test, and then we go. That is very important. Example. So now consider this series summation n factorial by n power n. Now what is un? So un you can take n factorial by n power n. So what you have to find the quotient, the un plus 1 by un. So the n plus 1th term by nth term. So if replace n by n plus 1, we get n plus 1 factorial by n plus 1 power n plus 1. Replace n by n plus 1, we get un plus 1. Divided by un. So what is un? We have denominator is n factorial, numerator we have n power n. Now already know that this n plus 1 factorial can be written as n factorial times n plus 1. Because n plus 1 factorial is nothing but product of first n plus 1 natural number. If you take the first n natural number, that is nothing but n factorial. The remaining is n plus 1 into n power n. Okay. So in the denominator, we can take n outside. From this, you can take n outside. Therefore, we get n power n plus 1 times 1 plus 1 by n power n plus 1 into n factorial. So we can cancel n factorial and then we can cancel n power n. So what the remaining things are there is equal to 1. Again, still we have a numerator n plus 1. You can take n outside from the numerator. We have 1 plus 1 by n in the numerator. In the denominator already we cancel from this term. We can cancel n power n. Therefore, 1 n is remaining. And this is 1 plus 1 by n. So n plus 1 I am writing n into 1 factor. Again 1 plus 1 by n. Because power is n plus 1, therefore I can write this. So now we can cancel this n. Now as n goes to infinity, where this goes? So in the numerator, what is the limit? In the denominator, what is the limit?
So we can cancel 1 plus 1 by n.
Yeah, very good. Okay.
It tends to 1 by e, sir.
Okay, what is it, less than or greater than 1?
Less than 1.
Yeah. So this un plus 1 by u1 by is less than 1, therefore the series is converges. Therefore summation n factorial by n power n is converges by DLMS ratio test. So this is very important series, n factorial by n power n. Okay, regularly they will ask in the examination. Okay. We have some other thing. You have to find first. You have to find the nth term. That is very important. Okay. Sometimes if they some problem they will give directly the nth term. Sometimes they will not give the nth term. You have to find the nth term. So like that, you can see some problem. So 1 by 3 plus the second term is 1 into 2, not 1.2, 1 into 3. So 1 into 2 by 3 into 5 plus 1 into 2 into 3 by 3 into 5 into 7. So the consecutive odd numbers in the denominator, numerator the consecutive numbers. Okay, now tell me what is un. The numerator should be 1 into 2 into 3 into etc. n. Right? Now what is the denominator? So since look at the first term is the denominator the first odd number. Yeah, bigger than 1, okay? Or product of one number. So here product of 2 odd numbers. This is 3 odd numbers. Now what can you say about digits? 3 into 5 into 7 into etc. So actually 1 is also odd number, 1 is missing. Therefore, what is the
n plus 2, sir.
no? Why n plus 2? So what is the nth odd number? So the first odd number is 1, second odd number is 3, third odd number is 5, fourth is 7, and so on. What is the nth odd number?
2n plus 1.
So totally from 1 to 2n, there are 2n elements. In this, both the even number of, there are half of them is even, half of them are odd, right? So you start with the odd number, therefore you can take 2n minus 1 is also odd because 2n is an even number. Okay, and then if you take the next one, 2n plus 1, this is also odd number. But in this problem, we are not considering 1. We are start from 3. Therefore, you don't consider this odd number. You start from 2, 3, and so on. In this, the nth odd number is 2n plus 1. If you consider from 1 to 2n, the nth one is 2n minus 1, right? But here we are start from we are considering 3 here. Therefore, the nth odd number, sorry, n plus 1 the odd number. Therefore, this is 2n plus 1. Now this is the nth term. Any doubt? Now find the quotient un plus 1 by un. Replace n by n plus 1. You will get un plus 1. Find the quotient un plus 1 by un, and then cancel the common term. You will get some only one nth term. So that is what is un plus 1 by un. So the un plus 1, the numerator 1 into 2 into 3 into etc. n into n plus 1 divided by 3 into 5 into 7 etc. into 2n plus 3. Because if I substitute n equal to n plus 1, 2n plus 2, 2 plus 1 is 3. By un, again un is 1 into 2 into 3 into etc. n. And we get a numerator is 3 into 7 into etc. 2n plus 1. So we can cancel this and then the first n numbers. And here, so this is up to 2n plus 3. So this is an odd number 2n plus 3. So another before the odd number is 2n plus 1, right? So we can cancel up to 2n plus 1 terms. Therefore, remaining terms in the denominator is 2n plus 3. Therefore, in the numerator we have a n plus 1 remaining. The denominator we have a 2n plus 3. Now, as n goes to infinity, where this goes to? You can take n outside and then cancel. We have 1 by n format, and then we get goes to where? What is the limit? This. Take n outside from the numerator, the denominator cancel. In the numerator we have 1 plus 1 by n. In the denominator 2 plus 1 by 2. Because we can take this n outside, therefore we have 2 plus 3 by n. 3 by n goes to 0, therefore denominator we have 2. Numerator we have a 1. Therefore, this converges to 1 by 2. 1 by 2 is less than 1. Since the limit value is less than 1, therefore the given series is convergent. Okay. Therefore, summation un is convergent. Got it? So sometimes they will give the series like this is a number. Sometimes they will not give the nth term. You have to find the nth term and then apply the DLMS test. Okay, any doubt in this? Okay, sometimes they give some unknowns, some x or alpha in that series. For what values of x the series is converges. Okay, that is the next thing. Next exercise. Suppose we have a series like 1 plus x square by 2 plus x power 4 by 4, x power 6 by 6, and so on. Okay, can anyone tell me what is un? What is the nth term? So only is even power x square, x power 4, x power 6. Therefore, the nth term is, what is that? X
Or 2n.
2n by 2n. Okay. Now, for what values of x this series is convergent? Now you have to find the quotient un plus 1 by un. Apply the DLMS ratio test. So therefore, what is un plus 1? X power 2 times n plus 1, that is 2n plus 2 by 2n plus 2, that is
Sir,
un
then
plus 1.
for what
Yes,
value of n will get 1, sir?
n equal to 0. Okay, okay, actually in the series you don't bother about the some finite number of terms. Okay. So in the sequence also, you can after certain stage we can see. So maybe you can omit, you can don't bother about some finite number of terms. You can add some terms, you can subtract some terms from the series, and the value does not change here. So therefore, so what is the answer here? Un. So what is un? X power 2n into 2n. So we can cancel x power 2n, the denominator we get, in the numerator we have x square, and then we have, if you take 2n from outside from the denominator, then cancel the numerator 2n. So what will get remaining? 1 plus 1 by n, because you are taking 2n outside, you get this one. So therefore this converges to where? As n goes to infinity, this goes to where?
X square, sir.
X square. Okay. Now, when this series is converges, now tell me, when this un is converges? Is converges if
X is less than 1, sir.
x square is less than 1.
X square cannot be less than 1, no, sir. Then we can take x is less than 1.
Huh?
So x square, yes, sir, yes, sir.
If it is less than, because I am taking un plus 1 by un, not un by un. Sorry, not un by un plus 1. I am taking un plus 1 by un. Suppose if you want, you can take un by un plus 1, you get 1 by x square. And then if you are less than, okay, anyway, both are anyway, you can write. So if it converges, if x square should be less than 1. Okay. So that is what? Since assume that x is positive and x square is less than 1, therefore x less than 1. Okay, because if I assume that x is positive, then x is positive and then x square is less than 1, therefore x cannot be negative, okay? Because if x may be negative, but it's given that x is positive. Therefore, x is less than 1 is nothing but you can simply say x is less than 1. Because if you given that x is positive. If it is x, given that x is positive, they can just say x is less than 1. Suppose not given anything about x, then x square should be less than 1. So that means what? The x maybe lies between -1 and then +1. So this for only for values of x lies between these, the given series is convergent. Otherwise, divergent. Okay. So any doubt in this? So you try to solve the remaining problems in that book, you can find it. Okay, maybe the final one, you guess, either you can use any test and then tell me that summation 5 power n by n square plus 5, n equal to 1 to infinity. Is this converges? So what is un? So un is nothing but 5 power n by n power n square plus 5. Anyway. Now, how we can choose Vn? We are going to apply un by Vn. If it is non-zero, then we can say that. Or if you want to say that this is we can apply the comparison test also. So you can use comparison test. Can you find any bigger element compared to this? So how we can choose Vn? I'm just taking just 1 by n square. I'm going to check this number is 1 by n square is less than this. No, because here pi power n into n square. So I am not choosing this one. So we have to choose suitable thing, and then we have to either we can use our comparison test or question. Suppose I'm okay, work by question. Suppose I'm taking Vn equal to 1 by 5 power n. Then again we will get a
n square by 5 power n by n square, sir.
Yeah, 5 power n by n square. Okay, what can you do? You know about this series is converges or not? We don't know, right? Again, we have to apply. Yeah, anyway, you can choose, and then again you have to apply DLMS test for this Vn is converges or not. Okay, now you are taking this. It's nothing but you are choosing what you are choosing 5 power n by n square. Okay, now you are finding this portion un by Vn, right? So this is nothing but 5 power n by again this is 5 power n into n square plus 5, and then this is n square. We can cancel this 5 power n. The denominator can take outside n square. As n goes to infinity, this goes to where 1. Because you can take n square outside and then cancel the numerator denominator n square. We get 1 plus 1 5 by n square. This goes to 1. It's a non-zero number. Therefore, if it is both, if you know this is converges, that this is converges. Now, how you know this Vn is convergent? Now you can apply the comparison DLMS test Vn by Vn plus 1 by Vn. So that is 5 power n plus 1 by n plus 1 square. That is Vn plus 1.
Sir,
and this is 5 power. Sorry?
Diverges, sir. I used ratio test, sir.
Ratio test. Yeah, tell me.
By un. It's greater than, I got 5, it's greater than 1. So diverges.
Which one? What is your Vn? Same thing.
Un plus 1 by un.
Okay.
Ratio test.
Okay, you directly apply ratio test.
Yes.
Okay, so what is the value you get? Un plus 1 by un.
5.
5. Okay, then it's bigger than 1, therefore it's diverges. Okay, then we can no need to go the comparison test. Anything. Directly you can apply ratio test. Sorry, DLMS ratio test. Yeah. So that is un plus 1 by un is 5 power n plus 1 by n plus 1 square plus 5, and then Bn is it is 5 power n, and here n square plus 5, and we can cancel 5 power n. We have 5, and we can take n outside from this. Therefore, we have n square, and this is 1, and this is okay. Yeah, 5. This is bigger than 1, therefore it's divergent. Yeah, good. So similarly, just pick up some the series, and then you just apply either comparison test or ratio test, and then check. So first you will check, if possible, check as n goes to infinity, the nth term converges 0 or not. If not converges 0, you can directly say this is diverges. If it is converges to 0, you apply some test. First you start with the ratio test better. Okay, u1 plus 1 by u1. If it is less than 1, is converges, greater than 1 is diverges. If it is equal to 1, then we go to the next. Okay. Okay, any other doubt? At least we can stop now. Thank you.